Today we'll look at the second topic in using math in science, and today's topic is scientific notation. So scientific notation means that we write big numbers or small numbers in a format that looks like what you're seeing right there. Okay, so 6.02 times 10 to the 23rd. All right, that is a number that's in scientific notation. It's a big number. And right here, this number 6.02, that is the coefficient, and then the exponent, that is, or the power of 10, is 10 to the 23rd. The exponent is actually the 23, but usually we just say the whole thing is the exponent. Here's another one over here. What's this right there? 2.996. It's called the what? The coefficient. And this is the power of 10, 10 to the 8th. So when you write standard scientific notation, you should always, or when you write things in scientific notation, you should always write it in standard scientific notation, or else have a really good reason why you don't. And that means the coefficient has one non-zero number followed by a decimal and any remaining numbers. So, for example, 6, one non-zero number, and then the decimal right there, and then any remaining numbers. And then the exponent, what is that? That tells the number of places that the decimal is moved. So that means that if you wrote this number out in standard form, in decimal form, we would move that decimal 23 places to the right. Now, a positive exponent versus a negative exponent, what does this mean? A positive exponent means the number is greater than 1. A negative exponent means the number is less than 1. Let's take a look at two examples. 8.51 times 10 to the 5th. That 10 to the 5th means it's a big number. And so we move the decimal 5 places, 1, 2, 3, 4, 5, and it comes out as 851,000. 7.2 times 10 to the negative 6th, that does not mean it's a negative number, it just means it's a small number. And in this case, we're going to move the decimal 6 places to the left, 1, 2, 3, 4, 5, 6, so that it looks like a small number. So there's the decimal, 0.00000072. Now, can you have negative numbers? Sure you can. But then you put the negative sign out here in front of the coefficient. Negative 1.3 times 10 to the 5th, that's a big negative number, kind of like my bank account. And this number is, let's move the decimal 5 places to make it a big number. 1, 2, 3, 4, 5. It is negative 1, 2, oh, I'm sorry. It's a big number. Sorry, start that over again. Negative 1, 3, and 4 zeros, 2, 3, 4 zeros, so 130,000. This one is negative 2.4 times 10 to the negative 3rd. It's a negative number, and it's a small number because it's 10 to the negative 3rd. It's a small number. So this is negative 0.0024. And here's some more examples down here that we could try. But you should give those a look and make sure that you feel comfortable in this. Here, all the examples that you need are right up here. So these examples should give you the information you need to practice with those problems. But we'll not take the time right now. Now, what about when you use scientific notation and calculations and you don't have a calculator nearby, or you just want to do this very quickly? Well, there are some rules that you should know, so please write these down. When you're multiplying using scientific notation, you multiply the coefficients and you add the exponents. Got it? When you're dividing using scientific notation, you divide the coefficients and you subtract the exponents. Write it down. Now, multiplying and dividing are actually easier than adding and subtracting. Let's take a look at a couple of multiplying and dividing problems. How about this first one? 2 times 10 to the 23rd multiplied by 2.5 times 10 to the 4th. Well, 2 times 2.5, we multiply the coefficients. I believe that is 5. 2 times 2.5. And then you add the coefficients. So this is times 10 to the 23 plus 4 is 27. Let's try this division one here. So you take 6 divided by 3, and that is 2 times 10 to the, what do we do again? Oh yeah, we subtract the exponents. So it's minus 18 minus 8. So that is negative 26, I believe. All right, now let's take a look at adding and subtracting. All right, this is a little bit tougher actually, because you have to, the first thing you have to do is make sure that the exponents are the same. The exponents, these powers of 10, are the same. Then you add and subtract the coefficients, and the exponent just stays the same in your answer. So you don't add them, you don't subtract You don't add the exponents, you don't subtract the exponents, they just stay the same. Let's try this number, this one right here. So you look at this, we're adding, I should say. So the answer is going to be times 10 to the 7th. Just leave that alone. And now you add the coefficients, 3.4 plus 2.6. That's 6, sorry. 6 times 10 to the 7th. But what happens when you do an addition or subtraction problem and the powers of 10 are not the same? In that case, you have to get both of the powers of 10 the same. So usually what you do is you pick either one, 10 to the 4th or 10 to the 3rd, and you adjust the other one by making it a non-standard format. So 10 to the 4th, 10 to the 3rd, I think I will go eeny, meeny, miny, mo. I like 10 to the 4th. So I'm going to take and change 10 to the 3rd to 10 to the 4th, but I have to adjust the coefficient over here. The 2.1, I'm going to move that decimal one place because I just changed it from the 3rd to the 4th. Here we go. So it used to be 10 to the 3rd, now it's 10 to the 4th. That's a bigger number. Okay, so that means I have to compensate by making this a smaller number, or 0.21. So my answer will be times 10 to the 4th. And then I'm going to subtract 9.8 minus 0.21. So that'll give us 987.7.6 or 7.59, I guess it would be, wouldn't it? But about 7.6 times 10 to the 4th. Here's another one. All right, remember what you have to do is get either one of these, change either one of these so they're both the same. 10 to the negative 6 or 10 to the negative 7th. The answer will end up the same no matter which one you choose. So if you say like, oh, I like 10 to the negative 6th, you're going to turn this one to 10 to the negative 6th. Here's how you do it. You say, well, it used to be 10 to the negative 7th. I've changed it to 10 to the negative 6th. I've made it actually bigger. So I have to compensate by making this one smaller by one place because 7 and 6 are only one apart. So it's minus 7.8 plus 0.2. So I believe that is minus 7.6, isn't it? Times 10 to the, leave these the same, negative 6th. All right. So now what about using a calculator? Now, it would be great if everybody had the exact same kind of calculator, but we don't. And so you're going to have to work with this a little bit to figure out what you should do. So if you had the number, I just picked a number at random, 4.55 times 10 to the negative 7th. What are some of the ways you might have to plug this in? If you have a TI-83 or TI-84, what you do is you plug in 4.55, I'm doing this one right here, 4.55, and then hit the second EE button and then negative 7. If you have most of the other types of calculators like this one here, or Casio's, you'd plug in 4.55 EXP instead of EE, negative 7. If you have a TI Inspire, it would be 4.55 10 to the X, negative 7th. So let's solve some problems using our calculator. I'll use this blue one. I like the blue one. All right. 7.7 times 10 to the 23rd. So I plug in, there we go. 7, second, EE, 23. And then I'm going to multiply by 2.9, second, EE, 4. Answer is 2.03 times 10 to the 28th. 2.03 times 10 to the 28th. So take a look at your calculator, make sure that you understand how it's written. It might say EXP or it might say EE here, something or other. All right, I have another calculator that I can use for one more problem, and that's the one that's on the computer. Okay, let's do the second problem. 5 times 10 to the negative 18th. 5. This one you have to hit exp. Negative plus or minus 18 divided by 2.3 exp 8, exponent of course, hit equals, and the answer is 2.17 times 10 to the negative 26th. 2.17 times 10 to the negative 26th. Well, there's a whole bunch of other numbers here. We'll have to learn how to round those off later. Okay, so that's today's lesson. Let's take a look at what we did. First, we said that scientific notation is used for big numbers and small numbers, and we have a coefficient and an exponent. And let's see, We said that positive exponents mean the number is bigger than 1. Negative exponents mean the number is less than 1. We said that negative coefficients mean that the number is negative, that is to the left of 0 in a number line. And we can switch these back and forth between scientific notation and decimal notation. We looked at the rules for using scientific notation, which I expect you to know, so make sure you really take a good look at that. And then we used scientific notation with calculators. So I hope that wasn't too hard for you, but if you have any questions, as always, make sure you stop in before school, after school, during lunch, or 6th hour. And thanks a lot.